Hello 1B class. This is for lesson for 7.8. Okay, 7.8. We learn about improper integrals. What's improper integrals? Okay, there are two types, and I'm gonna break the video into two parts. First part of the video, we're gonna learn the first type. The first type, you're gonna see the integral has limit like a infinity to a, or infinity to or negative infinity to positive infinity. You know that you cannot use infinity as a limit because it is not a number. So when you have this type of integral, you know this is called the improper integrals. Okay, so that's how the name comes from. So when you deal with improper integrals, so let's say I pick the first one, you need to use called linear approach. Why? Because this one doesn't count as a number. You can only approach infinity. You cannot equal to infinity. So therefore, we're going to go b approaching. We're going to let b approaching infinity and then a to b. Okay. So this infinity replaced by b, and then you will have a two possible answer. If we actually get a number out, if the limit exists, and this integral we call converge. It means it converges to a numbers. Okay. If the limit does not exist, this is dne does not exist, and then this integral will diverge. It means you have no control. Like you don't convert to a number, it goes to infinity, or does not exist. And so that's including if they have an infinity answer, positive, negative infinity answer. Now, for this type, okay, the last type, if this function f of x is a polynomial function, then you're going to break this integral to be negative infinity to 0 plus 0 to infinity, and then use a linear approach. If this function is a rational function, means a fraction, then you're going to use undefined point to break, like the denominator. Okay, the denominator, which point we can define, you use that to break. So now we're going to see some examples. So this video just for the first type. Okay, the second video I will do the second type. And so let's look at problem number 6. Number 6. Okay, number 6 we have from 0 to infinity, and 1 divided by root 4 1 plus x dx. So we could not, okay, because this tells us this is improper integral. So we have to use a limit approach. So that equal to limit b approaching infinity 0 to b, and I'm going to make this to be 1 plus x to the negative 1 over 4 dx. So that's equal to limit b approaching infinity, and integrate this one. This one is pretty easy to integrate because a constant plus x means a dx. Okay, this means nothing. Okay, don't even worry about it. You just keep write 1 plus x, negative 1 4 plus 1, negative 1 4 plus 1, and then 0 to b. And b goes to infinity. So this is 3/4. Flip it. It's going 4 over 3. 1 plus x. This one is 3/4. 0 to b. Now put the b inside. 1 plus b to the 3/4, subtract 4/3, 1 plus 0 to the 3/4. And that just equal to 4/3, okay, because it is a 1, so that's gone, just a 4/3 here. And when b goes to infinity, that will be infinity, right? Because a 1 plus infinity is still infinity, okay? So infinity subtract, this is whole thing is infinity here. Infinity subtract number still infinity. So your answer is infinity. So when you get infinity answer means the limit does not exist. Limit means you got to have a number. This is not a number, so therefore it becomes diverge. Okay, so this is diverge. So that's how you do this problem. And let's try the one, number 12. Number 12, we have negative infinity to positive infinity. Y cubed minus 3y squared. And then dy. And this one we're going to break it because this is a polynomial function. Okay, polynomial here, negative infinity to positive infinity. So we're going to break this into two parts. We use a 0 as the breaking point. Okay, then linear approach. And then linear approach here. And then integrate this one. 1 over 4y to the 4th minus y cubed. Oh, I forgot to put the limit sign. Sorry, right here. Sorry about that. Integrate this one is a 1 over 4 y 4th minus y cubed b0, and this is the same thing, and with same integral. And then it's 0b. And then now put the negative b inside here, negative infinity, so that become positive infinity. Okay, minus this is a negative infinity here, 2 negative. So q power still negative, so it becomes positive infinity. And so we're going to, this is, hold on. This is, sorry, I jumped the steps. I forgot to put the b inside first. Sorry about that. So this is 1/4 for b to the 4th minus, why do I have something like this? B, 0 go inside 0, minus 0 to the 3rd, subtract, b go inside, so 1/4 b to the 4th minus b to the 3rd, and that's for this one. Okay, I'm going to wait for this one. Okay, sometimes when this is a infinity, then this will be infinity. I don't even need to worry about it. So I'm going to, when you break the interval, also do the first one first, and then see how it goes. With this diverge, this will definitely have the diverge. It follows, it doesn't matter because diverge plus the converge is still diverge. But if this is converge, you have to do that one. Okay? That becomes, that's a 0, 0, so that becomes 0. Okay, so this whole thing just a 0. And this is a negative 1/4 of b to the 4th plus b to the 3rd. When I put in negative infinity inside, so that will become negative 1/4, and negative infinity still positive infinity. This is a negative infinity to the 3rd part, still negative infinity, so it comes cycle negative infinity. So it's a diverge. Okay, and then you don't need to do the second part. It doesn't matter this is converge or diverge. If as long as this diverge, then you add together, it's still diverge. Okay, so that would be for number 12. And then if this is converge, okay, if this is converge, then you need to do the second part. Okay, to see the converge or diverge. As long as one of them is diverge, then the whole thing will diverge. If one of them is converge, then you need to check both. Okay, if another one is converge also, then you converge. Another one diverge, then you diverge. As long as one of the integrals is diverge, then the whole thing will be diverge. And let's look at number 18. To the infinity dv over v squared v squared plus 2v minus 3. Okay, so we're going to factor this one first. And when I factor this, it becomes v plus 3 and then v minus 1. So that means this break it by partial fraction. Okay, break this by partial fraction. So then the LCD will be v minus 1, v plus 3. Okay, so 1 is equal to AV minus A plus a BV plus 3B. And then to save time, I'm going to tell you when I solve this, okay, A plus B equal 1, and then negative A plus 3B is equal to 0, and this equal to 1. When I add together, this becomes 4b equal to 1 and b is equal to 1/4. And then a is equal to negative b equal to negative 1/4. So that means this is equal to 1/4, negative 1/4. Okay? So I comes out, so I break these two. So I'm going to use this will equal to, I'm going to do right here, and limit b approaching infinity. I'm going to break the two of them, okay? 1/4, I take it out, and 2 to b, 1 over v plus 3. And then, this is b. And then I take out the 4, so this becomes negative. I take out 1/4, that's become negative. I take out 1/4 here, okay? This is negative 1 over v minus 1 dv. Okay? And then now this is just a logarithm, okay? So this is ln v plus 3 minus ln v minus 1 and 2 and b. And remember I mentioned that before, I said it doesn't matter what you have here, adding or subtracting, it's just logarithm. Okay, so this means nothing here, because when you take the derivative, that is just equal to 0. I'm going to put these together, okay? So I'm going to put it together. And that becomes ln b plus 3 over v minus 1. It's just easier for me to, so when I see an logarithm, I like to put it together before I put in the limit, just easier. So I take out the 1/4. And then that becomes ln b go inside the b plus 3 over, oh, I'm sorry, this is a too little here. B plus 3 over b minus 1. Subtract, put a 2 inside, ln 5 over v minus 1 is a 1. So ln 5. And so that's equal to let's look at here. When b goes to infinity, okay, maybe I erase this part, so I'm going to continue here, okay. Erase it. And I take out this part. Oh, I forgot to put the ln. So ln, b goes in infinity. And then if b goes to infinity, infinity plus 3, infinity minus 1, so that becomes infinity over infinity. Okay, L'Hopital's rule. So that becomes L'Hopital's rule, that becomes 1 over 1, so that's a 1. Okay, and then subtract. I forgot the 1/4. So this whole thing has to be multiplied by 1/4. So minus ln 5, and this whole thing times by 1/4. So you can see ln once equals 0. Okay, so your answer equals negative 1/4 ln 5. So that's a converge. Okay. So that's for, so this part use L'Hopital's rule, okay? This one I use L'Hopital's rule. Maybe I put a H here, so I use L'Hopital's rule. And then this come from this portion, okay? I just take out this portion first, and that's right there. So I take out, I put it right here, and then now I put back with this one. So that's how I get. So it means that this one goes to 0, so this will go to 0 because ln1 is 0. So all I have is just this one, okay? So because I only have that one, so it's a converge. So therefore, this finish the first type of improper integrals. So first type improper integral have infinity. Okay, watching it, when you have infinity, that's how you do it. You got to use the limit approach because infinity doesn't count as a limit. And I will do the second type later on.